empty, yeah? And you can see that the null position of 18 is not contained in this interval. It's actually on the left-hand side of this 18.84, yeah? So that's how we, once again, how we can figure out whether we reject or not based off confidence intervals. And the sample average hasn't changed. It's $19.78 or $19.79, okay? So that was how we did a t-test, that's how we did a t-test, single sample t-test, single-sided or single-tailed, the greater than side. In other words, this is actually a right-hand tail test. What about a left-hand tail test, the less than version of this, okay? So once again, I'm going to go t-test, okay? T-test, open and close round brace. The data set is tips, and actually the frame that we're looking for in there, or let's say the data column that we're looking for, or the vector, is total bill, okay? Followed by a comma. We specify the alternative. Alternative is equal to, in this case, it's less to signify the less than alternative, and this time mu, let's say mu is equal to, I suppose the question that we have is there any evidence to suggest that the mean is less than, let's say, we already know that the mean, there's evidence to suggest that it's greater than 18, yeah? But let's ask the question, is there any evidence to suggest that the mean is less than $19, or is there any evidence to suggest that the mean is less than $20, okay? Let's use that as an example. Is there evidence to suggest that the mean value is less than $20? So I'm going to hit return on that, okay? And once again, we get a test statistic of minus 0.375. That's indicating that the test statistic is on the left-hand side of our distribution. Okay? Degrees of freedom are still 243. But this time the p-value is 0.35. Once again, if the p is low, the null must go. And the p isn't less than 0.05, so there's no evidence for us to suggest that the alternative is true. Okay? And once again, you can see the 95% confidence interval actually contains the mu value here. Okay? So that's how we do the t-test. That's the 3 variants of the single sample t-test. Maybe something that might be important for you is to store the results. Of the t-test inside a variable. Okay, so let's do that. So let me say t-test results. Okay, actually let me just do this with camel case. T-test results. Okay. Results, and I'm going to assign into t-test results the results of one of my t-tests. So let me just take the first one here. I'm just going to take that there, just copying that, and I'm just going to put that here. So let me just go Control V. Okay, so it's going to run the t-test under these conditions. Okay, that was the first t-test we did, and it's going to store the results in t-test results. Okay, so I'm going to hit return on that, and we've stored the results in there. Okay, so now what I can do is, let me just clear this off. Okay, what I can do now is I can now access all the statistics, yeah, okay, that are associated with that particular test. Okay, so for example, I might say t-test. Let's access our variable t-test results, and this time what I'm going to ask for is, okay, $1. You can see I can ask for the statistic. That'll be my t statistic. I can ask for the parameter value, okay? I can ask for the p-value, the confidence interval, the actual estimates, the null value, the alternative value, and the method that was used, okay? So let's just walk through them one at a time. So let's get the statistic. You can see that the t-value is 1.37, okay? Let's do it again, but this time let's ask for the parameter, okay? The parameter, okay, is the degrees of freedom. It's 243. Let's also ask for, this time, let's ask for the p-value, the actual probability of observing that particular test statistic here. Okay, we get it's 0.169. Let's do it again, and let's ask for, let's say, the confidence interval. Okay, so the confidence interval is, well, it's from 18 up to 20. Okay, let's do it again. This time, let's ask for something else. Okay, let's ask for the estimate. Okay, it's the mean value, that's the estimate associated with the sample data. It's 19.78 or 19.79 rounded to 2 decimal places. And let's ask for the other I suppose the other parameters that we have access to. The null value. Okay, the null value was set to 19. That was the mean value. Okay, that's associated with the null hypothesis. Let's ask for the alternative hypothesis. The alternative is a 2-sided test. Let's ask for, well, what else can we ask for here? Okay, let's just go down here. Okay, and we can ask for, let's say, what's the method that's been used. Okay, it's a one sample t-test. So really what we have here is that when we store the results of our t-test in a variable, okay, what we can actually do is we can actually access those particular results, yeah, for some other calculation that we might rely on those results for. So for example, if I'm going to plot a graph of the t-distribution, okay, and if I'm going to put in the critical values associated with this particular test and also the test statistics, so that I can actually show that the test statistic is either greater than or less than the critical values, okay, well, I'd need access to the test statistic, in which case by me storing the result of the t-test in this variable t-test results, I can always access the test statistic and I can always use that value later on. Okay. I know it was quite fast, okay, but what we're really trying to get across here is that it's really straightforward to do these tests once you know the name of the functions and once you know the parameters that the functions take within RStudio, or with respect to your statistical programming language. Yeah. Okay. So that's really it. So once again, guys, my name is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video was in some way intuitive, and more importantly, I hope that was actually helpful for you, and thanks for watching. Okay, bye bye.